So for this function, the first thing you want to do is you want to see if the function is continuous. And remember, the question of continuity is really a question about we want f. If it has a denominator, we want to make sure that denominator is not equal to 0. If it has a radicand, we want to make sure that whatever is inside of the radicand, whatever is inside of that, is greater than or equal to 0. And if we have a natural log, we want to make sure that the argument is strictly greater than 0. So that really is the question that we have for continuity. So in this case, we do have a denominator. So we know that this function will be continuous if the denominator is not equal to 0. So if I set this denominator not equal to 0 and solve, I would take the square root of both sides and I would get that x cannot be equal to plus or minus 0. So what we are saying here is we're saying the function is continuous if x is not equal to 0. Now, this is an issue for us because we need the function to be continuous from -1 to 1. And the place that it is discontinuous is at x is equal to 0. So at x is equal to 0, it is discontinuous. So because it is discontinuous at x is equal to 0, we would have to say that the mean value theorem does not apply. And it's because, just to start off, I mean, without even thinking about differentiability, the function also is not going to be differentiable at x is equal to 0, but it's because it is not continuous at x is equal to 0. And that point is inside the interval of interest, so the mean value theorem does not apply.